In this podcast, we're going to talk about Rutherford's gold foil experiment. In this experiment, he shoots alpha particles at a thin sheet of gold foil. Now, alpha particles are the equivalent to a helium nucleus. So essentially, you have 2 protons and 2 neutrons. They're fired at the thin sheet of foil, and then wherever they deflect off, they are recorded on a detection screen, and that's this big blue part up here is the detection screen. Alright, so here's a different rendition of it. You see you have the fluorescent screen, and here's our piece of gold foil. We have a lead block, and then we have some uranium. The uranium is going to let off the alpha particles. He expected for the alpha particles, the stream of alpha particles, to just go straight through, because he thought that the mass in the nucleus was distributed evenly. Not in the nucleus, in the atom, I'm sorry. Now, when he actually did this, what he saw was that some went through and some were deflected into these odd patterns around the nucleus. Around the atom. He thought, that means there must be something in the center, like the nucleus. So he thought the atom is mostly empty. That's why we see most of them going straight through. But in the center, there's got to be this small, very dense, positive piece that's deflecting some of these alpha rays. And if the alpha rays get close enough, we see that they're deflected onto the fluorescent screen. So we see here, the majority of them are going straight through. Then you have a couple of them that once they get close, they either curve off, or if they go straight at it, they'll actually deflect straight back at you. So here is another example. We have 2 shapes. See if you can figure out what sort of shape is beneath them. We see the first one is a triangle and the second one's a circle. So this is similar to the activity we did in class, Rutherford's roller, where you had to determine things that you weren't able to see just based off deflection patterns, which is essentially what Rutherford did during his discovery of the nucleus. So Rutherford's findings were that most of the particles passed right through. A few particles were deflected. Very few were greatly deflected, though. But however, some were deflected. This tells us that the nucleus is small, it's dense, and it's positively charged. So we now have a much better view of the atom. Throughout this whole process of developing the model of the atom as we know it today, we've seen that every time we get new experimental results that don't add up with our model, we have to modify our model. This is how you test to see if your your scientific model is a robust model or not, if it's a good model. If it can explain lots of experimental results over varying laboratory experiences and circumstances, then it's a good model. If it can't, then it needs to be modified so that it does better fit with the data.